Hi everyone, my name is Mahmoud Elhadidy, a PhD student at the Computational Biomechanics Group, Mechanical Engineering Department at University of Utah. We also work at the Scientific Computing and Imaging Institute, known as SKI at University of Utah. Today I'll be explaining how you can automate your CFD generation for aneurysmal blood flow inside Ansys. The automation will be done inside Python. For the geometry generation, we will be using SpaceClaim, the CAD modeler inside Ansys, but the script will be automated in Python. For the meshing and for the simulation, we will be using PyAnsys, using PyPrime for meshing and PyFluent for the simulation. For the post-processing, I used Python, VTK, and ParaView, which I won't be explaining in these tutorials as they are already explained in other tutorials in our YouTube channel. Provided by Dr. Amir Arzani. You can check them. Starting with the geometry, our geometry is simple but still representative, and it's consisted of a 3D idealized artery with an aneurysm, and it has 4 spatial parameters, 2 for the aneurysm itself, consisting of the width of the aneurysm and the neck of the aneurysm. For artery, we have 2 parameters, the curvature radius of the artery and the artery diameter. Moving into the mesh, we used polyhedral element inside Ansys. You can see in the left the exterior mesh, and on the right we have a sectional view of the interior mesh. We used also inflation layers near the wall to capture the steep gradients, and we will be checking the mesh quality during the mesh generation as well. Third step, which is the simulation, we have a transient laminar simulation, and we have blood as the working fluid. You can see the velocity inlet profile, which is consisting of 4 cardiac cycles. And on the left, we have the concentration inlet profile, which is just a step function off and on. So speaking in high level, we have 3 tutorials. First one, geometry inside Ansys SpaceClaim, then meshing inside Ansys PyPrime. Finally, the solution inside PyFluent. So let's begin, and I'll see you in the first tutorial.